All right, so I'm going to run through this one more time. We added 2 tests to it. So the first test can push and pop from the stack, creates a new stack, pushes 2 items into it, then pops those 2 items, and asserts the first time through, you get the last item. Second time through, you get that last item, do it again, and you get no. Then we test our reverse method by first creating a new stack, pushing 3 items into it, popping them off, assuming that it'll be 3, 2, 1. We push them back on, 1, 2, 3. Then we call reverse list. And this time when we do reverse list, we pop 1, 2, 3 instead of 3, 2, 1. So we reversed it. If all that is true, then our test is in fact working just fine. All right, so we initialize. It creates a data of nil. We look for a value. This is just initializing. Blah, blah, blah. It should be finished initializing. There we go. So it initialized. Then we're going to push, and it's going to look for the value. It says if there's some data, which there isn't, then find the next node at the end. That's what tail does. Find the last item, grab its next node item, and then add that value to it as a new linked list. Otherwise, just create a new linked list on data. That is what it's going to do. So we got a value of 1, and then whenever it's through with this and returns it, our stack now has a data module with a next node module set equal to nil. Then we're going to push 2 onto it. This time if data is true, so it looks for that next node, which next node is now equal to nil, and it says create a new linked list node with the value of 2 set to it. So whenever we jump over that, we get to our tail method. Tail says look for the data, and if there isn't any data, return nil, but there is data. Return the node if there is not a next node on it, which that's going to be true in this case, because if we look at our node and we look at next node, it's equal to nil. So it's saying go ahead and return this because why? It's finding the last available data structure. And the last available data structure is this one because there's nothing that comes after it. There is no next node. So this is okay, return that. We reinitialize our linked list, and then we call pop. Pop says the last is equal to the tail. So first it finds the tail. So if there isn't a node, return nil, there is a node. If there isn't a next node, return that, but this time there is a next node. So now it says, okay, run through every single node looking for the next node property. As soon as you can't find it, return it. So go through everything until you can't find any more next nodes. So go through here, next node, nope, next node, yes. So it only went through one loop. If there is a last, so if this doesn't return nil, because that's a possibility, then I want to delete that value out of there because that's what pop does. It returns the last value and then deletes it. That's why we get nil at the end. So we delete that last value. Then we say, okay, if the data value is equal to the value, so if there's only one item in this, so in this case it would be if there's no next nodes, only this thing, return that. That is not true. So then it says, okay, I want you to find the node that occurs before this particular value. So we run through that. Find before looks at the node. It starts off at data. So that's always the top level. Then it says return false if there isn't a next node. So if we know that if this is the last node, it must be the one before the value. Then it says, well, if that isn't true, then look for the node, the next node's value. And if that's equal to the value we're looking for, which in this case we're looking for 2, then that should be good. So we've got our node, which is equal to 1. We've got its next node property right here, and the value of that is equal to 2. That's the value we're looking for, so it's going to return that value, or that node. It does, and it says that 1 is the node that occurs before 2. That is correct. And then it says find this thing's next node, and then set its next node equal to the value that we found before. Or excuse me, set its next value to 1 after it. So it's going to basically delete it out of there. So there was a last method that gets returned. So last is equal to a node value of 2, and that got removed from the next node right here. So that node.nextNode set equal to the node that it deleted's next node, which in this case was nil. It returns that. We assert that it's equal to 2. It is. We run through this again. It deletes it again, and then returns what it finds. Then the last time through, if last, there is no last, right? Because if not node, return nil. So if there's a last, return it, and then we return last, which in this case is nil. So boom, nil is true. Then it runs through some test stuff, none of which we need to worry about. Then we reinitialize the stack. It does the same things we've already seen. All the same methods, all the same actions. Nothing new or interesting really going on here. And finally, we get to our reverse list. So the first thing this one does is he didn't really define what he wanted reverse to do. Does he want it to change the node in place, or does he want to preserve the node, or does he want to delete the node? I don't know. But it's very important that the first thing that we do is we create a data copy. So marshal.load, marshal.dump says deep clone this, because if we just set old node equal to @data, it would not clone it, it would simply reference it. And every time we affected the @data module, it would also affect the old node. That is exactly what we want to have happen while we're running this loop for this node thing. So each time it runs through, we want it to mutate, but we don't want to mutate the old node. So then every time it runs through, it pops off the last element. Let's see if we can get there again. Right. It says find the last element, and then in the new list we created, take that last element and put it into the first spot. So we're reversing it by doing that. So each time through, it finds the last element and then makes that the first element until there are no more elements left to do that to. Okay. So then in order to preserve our data, because right now data is nil because each time through it deleted out of there, we're going to set the data equal to the old node, which we cloned above. So that old node still is preserved. It did not lose any of the values that it originally had. So we do that, and then we return our new list because we were meant to reverse this one. We could also create an @reversed, and we could reference that in our attribute accessor there. That would be another way to do this. But for right now, we're just simply returning the reverse list, and then we assert 3, 2, 1. Or excuse me, 1, 2, 3. So the exact opposite of what we got above it. Sure enough, that's exactly what's going to happen. 1, 2, 3, and then nil. And with that, all the tests pass and everything runs perfectly fine. So just to see that in the terminal, we can see quite clearly that it passes very easily. So that is the walkthrough of what happened whenever we run through that linked list. Where is my linked list? There we are. So that is the solution for what actually happens there. It involves a lot of whiles and ifs and unlesses. Like, you need to understand conditional logic in order to get this. But once you understand conditional logic, this is all really simple. It's just made up of several parts that look complex, but there's really nothing that interesting going on here. Just looking for the value. If it has it, we return it. Otherwise, we return false. We loop through until we find it. If we can't find it, we return nil. And that's basically how this goes.